Okay, so we are going to solve problem 35 from chapter 3, Giancoli 6th edition. So what we have is a plane. This plane is up here, moving with a horizontal velocity. The magnitude of this velocity is 69.4 meters per second. And far from this plane, there is a mountain with some people lost there. So the plane wants to send them food. Okay, this plane is 235 meters above that mountain. Okay? And it is a certain distance away in the horizontal direction. Okay? So the first question that we want to solve is the following. How far in advance of the recipients, that is, what is the horizontal distance that the goods must be dropped so that they will reach those people. Okay, so the question is, what is this x? If I want x, I'm going to go for this equation. X equals to x naught plus vxt. Alright, so this is part A. Before trying to put numbers there, let's choose a reference frame. So I'm going to choose that to the right is positive, and I'm going to choose that pointing down is positive. Okay? This means then my g is positive plus 9.8 meters per second. According to this frame, then my initial position is 0 in the x and in the y direction. The initial velocity in the y direction is also 0. Okay? All that we have is a plane moving in the horizontal direction. What we are going to do is open the doors of this plane and let the goods fall. And we want them to fall so that they can reach these people on this mountain. So we want them to follow this kind of trajectory. Alright, so let's now put the numbers into this equation. The final position, I don't know. That's what we want to find. X naught we know is 0. Vx we know is 69.4. But the time we do not have. So what we are going to do, we go to the horizontal, the equation for the vertical motion to try to find that time. So y is equal to y naught plus v naught yt plus g over 2t squared. And so this is a good choice because I do know what is the final position in the vertical direction. It's 235. The initial position is 0, the initial velocity is 0, g is pointing down, and down for me is positive, so 9.8 divided by 2, t squared. So from here I get the time, and so I get how far in advance these goods should be dropped. Okay, now let's go to the next problem. The next problem is a little different. Instead of finding this position, they tell us that the goods are sent when the plane is a fixed position away from that mountain, and this a fixed distance in the horizontal direction, and this distance is 425 meters. So this now is fixed. The height is still the same, 235 meters. Okay, from that mountain. Okay, I'm going to choose again the same frame, positive to the right and positive down, so g is again positive. And what else do we have? Well, what we want to know now is what vertical velocity, up or down, I do not know yet, should the supplies be giving so that they still arrive at the climber's position. Okay, at the position of those people on top of the mountain. Okay, so what are we going to do? Well, the velocity of the plane in the horizontal did not change. It's still 69.4 meters per second. Now, to guarantee that the goods will reach those people, I'm going to give an additional velocity in the y direction. I do not know yet if it's down or up, and this is what we want to find. What else do we have? Well, according to our frame, the initial position is 0 in the x and the y direction. Okay? If what I want to find is v naught, the initial velocity in the y direction, I could go straight to the equation that involves that velocity. So y equals to y naught plus v naught yt plus g over 2t squared. Okay. Why is this a good choice? Well, the final position I know it has to be 235. The initial is 0. The initial velocity I don't know. So, and this is what I want to find. So I'm going to put here in red. I'm not going to put any sign because I do not know yet if it's plus or minus. Now comes the issue with time. Time I don't have. If I knew the time, I could solve this equation. So where can I find the time? So let me write the equation and think where I could find the time. So let me put the whole thing, 9.8 divided by 2t squared. Well, to find the time, I can go to the equation for the horizontal motion. To find the time and substitute it here, I go for the equation for the horizontal motion, x equals to x naught plus vxt. Because final x I know is the 425. Initial x is 0. Initial velocity is 69.4, positive because it's to the right. And so from here I get the time, and then I will find the velocity. You will see that from this equation we will get the sign of the v naught. So if the sign, if v naught y is positive, then according to my frame, I know that we are throwing the goods pointing down. I'm giving this additional velocity pointing down. Down for me is positive. If my solution gives me that v naught is negative, then I know that we had to throw the goods up to reach those people. Okay. Now the final question now is part C, which is once the goods reach those people there on top of the mountain, what is the speed? I know that it has the Vx that never changed, 69.4, still the same, but we also know that the Vy, that it has a Vy component which had increased. Okay, so to find, so this is the final Vy. So to find the final speed, I have to take both into account. So this is part C. Part C is what is the final speed once it reached those people on top of the mountain. So the final speed will be Vx squared plus Vy squared, so the square root of that. The Vx still the same that we had before, it never changed, it's 69.4 meters per second. And the Vy, well, to find the Vy, we need to solve the equation for velocity. And so the final Vy is the Vy naught plus g multiplied by time. So the Vy naught is what we found from here, from part B. The time is also what we found from here in part B. And solving this, we'll get the final speed.